Okay, we are going to re-record this lesson because the first one got messed up. So anyhow, in the first question, you are choosing really three things. You need to pick your 8 o'clock class, you need to pick your 9 o'clock class, and you need to pick your 10 o'clock class. So there's three things you're picking, and then you put your number of choices here. You have 7 to choose from for the first class, 4 for the second, and 3 for the third. One class and second class and third class. So you are multiplying, and you get 84 different ways you can make your schedule. Your travel agent is arranging your honeymoon, so you have several different choices to make. You'll be staying in 2 different hotels, taking 3 day tours, and eating at dinner at 5 restaurants. There are 5 hotels you can choose from. So I have 5 hotels. I am choosing 2 of them. I have 7 day tours. I am choosing 3 of them. And there are 11 restaurants, and we are going to choose 5 of them. Now, the question is, are you doing either or are you doing all of it? So you're choosing your hotel and your day tours and your restaurants. So that word "and" means you're going to multiply those. So think to yourself, it's not like I'm choosing a restaurant or I'm going to choose a hotel. I'm choosing a restaurant and a hotel. Okay, so you're going to multiply. Number 3 is a pretty basic question. You're looking at the table. What is the probability that a randomly selected degree will be business or psychology? So or means to add them together and subtract any overlaps. These are mutually exclusive. On my table, the first thing you should have done is add it all up. So you're going to add those 2 and divide by the table total, and you get 0.258. What's the probability that the degree is not in health? Well, the easiest way to do this is figure out how many degrees are not health, and then divide by the total. You could add up all the degrees except health, but that would be more work than what you need to do. It's easier to subtract 1 than to add 4 numbers together. All right, here we go. Number 4, you have 3 letters and 4 digits in the license plate. So they tell you the first letter cannot be an A. So this cannot be an A. The last letter cannot be a Z. And the digits can not repeat. The letters can. And all the digits have to be even numbers. So the even numbers are 0, 2, 4, 6, and 8. So there's 5 even numbers. So how many letters do we have that do not include A? There's 25. How many letters do I have total from the second one? It's 26. And again, there's 25 letters that do not include Z. We're allowed to repeat, so that's why we're going to use those numbers again and again. With the numbers, I have 5 even digits. The next one I've already used 1, so I only have 4 left, and then 3, and then 2. And again, you're multiplying. This is the multiplication counting principle. Okay. All right. A card is selected at random from a standard deck of 52. What's the probability that the card is a club or a 7? So the rule says, this is the union rule, you take the probability of A plus the probability of B minus the intersection. And you know what? I'm just going to add them. It's going to be easier. So if I do A union B, how many elements are in the set? A plus B minus the intersection. So in a deck of 52 cards, I have 13 clubs plus 4 7s minus 1 that is a 7 of clubs. Okay, so these are clubs. This is the 7s. This is the 7 of clubs. So I can draw a club. All right? So that totals to 16 cards out of 52. So your probability is 4 out of 13 or whatever decimal you have. I don't know if that's bothering you, but that club is really, really bad. I'm going to write a big one here. Not much better, but a little bit. Okay. So, in a sample of 28 puppies, 18 of them are labs, which are the coolest dogs on the planet, and the rest are silly little chihuahuas, least cool. If you grab 3 puppies at random without replacement, which means they are independent events, what is the probability, dependent events, what is the probability that all 3 are labs? So you have 18 labs out of 28 that you're probably picking the first puppy being a lab. And the second puppy is a lab. Well, there's only 17 labs out of 27 now. And the third puppy is also a lab. There's 16 labs out of 26. These are dependent events, which is why the probability is changing. None of them are labs. Well, there are 10 that aren't labs out of the 28. I pick a Chihuahua. I have 9 Chihuahuas left out of 27. I have 8 Chihuahuas left out of 26. Now, all labs, no labs. Those are not complementary events. Complementary events include, just between those 2 events, it includes everything. So we don't have the mixture, okay? So they're not complementary. Part C says at least one of the puppies is a lab. These are complementary to none of the puppies are labs. So no puppies are labs or at least one of them is a lab would be complementary. So we can just do 1 minus 0.037. You could go through all the possibilities. You'd have to have 8 different ones to add up. Or 7 different ones to add up. It's just easier to do complement. So recognize that complement. So this is the complement to no labs. Complement. Okay? 62 actors show up for an audition for the parts in the new movie about the Beatles. How many ways can the director cast the roles of John, Paul, Ringo, and George? Well, those are 4 different parts that they're going to assign. So when you are assigning parts, it is a permutation. So you have 62 actors, you're assigning 4 roles. It's, again, big number. And you can use your calculator to put the permutation in. An employer must hire 2 people from a list of 13 applicants to be the new computer techs. These are 2 identical jobs. So the order that they get hired or told about their hiring does not matter. So it's going to be 13C2. 78. Okay? So when order does not matter, it's a combination. When order does matter, it is a permutation. Now number 9. You have to be able to do this without the calculator. Without the one I'm going to give you, it's going to overflow your calculator. Okay? So you have to solve it by reducing factorials. So the numerator here is 67 times 66. This is what factorial means. And we could do this all day long. The denominator, first of all, 67 minus 65 is 62 factorial. Okay, so 62 factorial, let's do a little bit more on the top. As soon as I get to 62 and on down here, this part here is 62 factorial. So when I have 62 factorial on the bottom, this is the same thing. So those are going to cancel. So in your calculator, you're going to type in 67 times 66 times 65 times 64 times 63, and then you'll be able to divide by 5 factorial without overflowing your calculator. Or you can do 5 times 4 times 3 times 2 times 1 in the bottom as well. So you want to be able to reduce the factorials. Okay, a football team has 53 players. There are 28 that are on offense and 25 that are on defense. Suppose 7 are chosen at random to be drug tested. So again, is this a permutation or combination? Well, if I'm just getting my name put on the list, it doesn't matter the order that it's on there. It's going to get chosen. So it's a combination. So there's 28 offensive players, we are choosing 2 of them. And there are 25 defensive players, and we are choosing 5 of them. Out of 53 players, where we're choosing 7 of them. Okay, so you're going to split the numerator into offensive and defensive. How many ways can I pick 2 from the offense and 5 from the defense over the total number of ways to pick 7 kids at random? Okay. All right, number 11, you're just determining if they're probability distribution tables. You are looking for a table where the probabilities add up to 1. You do not see any negatives or numbers that are greater than 1. So in the first probability table, you've got this negative. So this is not 1. Has a negative probability. You can't have a negative probability. In the second one, we have this probability that's over 1. Probabilities are between 0 and 1 inclusively. Okay. In the third one, if I add up all of my probabilities, I get the sum equals 1. I have no negatives or any numbers greater than 1, so yes, this is a probability distribution. All right. Miss America pageant has 50 contestants, and at the end of the first day, they announce the 5 that are going on to the final round. So if you've ever watched this show, they always say, in no particular order, because it doesn't matter what order they're getting picked. They're starting fresh the next day, so their scores are being eliminated. So this is a combination. I have 50. I am choosing 5 of them. And that's how many ways they can choose 5 ladies from the 50 contestants. That decimal's in the wrong spot. Okay. Here we go. What's the probability that Miss Ohio is in the list of the 5 from number 4? So it's kind of like the football question, if you want to think of it. On the top, we have to split the ladies into people from Ohio. There's 1 from Ohio. I'm going to pick 1. And there's 49 other contestants that I have to choose 4 from. And there's 50 that I'm choosing 5 from. Okay, if that makes sense. That's how we're going to do that. And then if you put that in your calculator, you get 0.1. Okay. All right. 56% of the U.S. adults say they intend to get a flu shot. You randomly select 10 U.S. adult cities. What's the probability that you get exactly 4 that said they're getting a flu shot? So this is the formula, and you're going to get some of these formulas, guys. Okay, so it's a binomial probability formula. So exactly 4. So you have 10, choose 4, times 56% is your chance of them saying yes, they're getting a flu shot. You don't need parentheses if you're calculating that right. I'm going to put parentheses here just to separate. It's a little easier than this multiplication symbol. But you don't need them. And then the complement to 56% is 44%. If I have 4 that are getting it, 6 are not. And that would be 0.15. Now, I promise you on the test, these are going to be a little bit shorter. At least 5. So at least 5 means 5, 6, so on and so on until you get to 10. So you have to do all of those and add them up. I'm just going to kind of start this process. Plus and then you just pick the next one. I'm just getting ahead of myself. This is supposed to be 5 and 5. Looking up above. Plus, and you keep going until you get to 10. Choose 10. Okay, and after all is said and done, you should get 0.76. All right. So, it's kind of crazy. It's a lot of typing in when they don't want you to use the graphing calculator and look at the table and everything. So we are going to just have a little bit of a shorter one, but understand, at least, at most, less than. So if it's less than, it's going to be 0, 1, 2, up to 6, right? Less than 7. So you would do the same thing. You'd have to have all of those binomial things written out, and you would add it. And you get 0.71. So if you want to practice those, you can. Okay, find the mean, variance, and standard deviation of that question. Well, these formulas, the mean, I hate writing these U's. The mean is n times p. So the number of people is 10. The probability of success is 0.56. So my mean is 5.6. The standard deviation is omega squared. It's going to be n times p times q. So it's going to be 10 times 0.56 times 0.44. And you get 2.46. And then remember, the standard deviation is always the square root of the variance. So you always have to find the variance first. Okay? All right. How many distinguishable ways can books be placed on a shelf given that 3 are pre-calc, 5 are Algebra 2, and 4 are AP Calc books? So the word distinguishable is huge here. Okay? There are a total of 12 books that I'm arranging. So if I were arranging all 12, it'd be 12 factorial. But I can switch around my pre-calc books and you're not going to know the difference. So we have to divide out that repeating thing. And then Algebra 2 books, same thing. I could switch those around and you wouldn't know. So you have to divide by the repeated parts factorial, okay, each separately. So if nothing repeats, you would just have 12 factorial. But considering we have all those books that are repeating, you have to divide by each of those factorials. Make sure you put parentheses around the denominator. This has to be in parentheses or it's not going to work very well. All right, number 17. This is the last question. So you have to total the number of employees you have here. You add up the number of employees, there's 192. Then you need to find the relative frequency, which, by the way, is the probability of each of the number of types of overtime hours. So 6 divided by 192 is 0.03. 12 divided by 192, 29 divided by 192, and so on. So we are just, and go ahead and round to 2 decimals as long as there's something there. If you have to go further because it's a real small decimal, you can. Now, it's always good, because this is a probability distribution table, to make sure your things add up to 1. Understand, when you're rounding, sometimes it'll be off a little bit. In the grand scheme of things, when we're doing our mean and all that stuff, it's not going to matter. But these do add up to 1. We rounded pretty well. So then we want to find the mean. So this is the formula for the mean, is the summation of each x times its probability. So you're going to do 0 times 0.03 plus 1 times 0.06 plus 2 times 0.15 plus 3 times 0.3 plus 4 times 0.22 plus 5 times 0.16 plus 6 times 0.08. And you're going to find the mean to be 3.42. All right. The standard deviation, if you remember, we had a shortcut to our formula. So the actual formula says x minus the mean squared times the probability. But the shortcut one says the summation of x squared times the probabilities minus the mean squared. So much easier. Much easier. So I'm going to take x squared. So it's the same formula that we have in green above. But instead of just x, I'm going to square the x's. So 0 squared is still 0 times 0.03 plus 1 squared is still 1 plus 2 squared times 1 plus 9 squared. So we are just squaring our x's before we multiply for the probabilities. We're going to get that number. And then we got to subtract the mean, which is 3.42 squared. Let's put that in a different color. So this part here, we're subtracting. So our standard deviation is 2.06. And then remember, our variance is 2.06. The standard deviation is the square root of the variance. Always, always, always. And you get 1.44. Okay? So you will have the formulas that you need on the test. And practice. There's extra problems in your textbook at the end of the chapter. And I do believe the answers are in the back of the book.